our unit 1, which is going to cover the real number system and some of our exponent properties. So these letters and numbers down here represent our core. The 8 stands for 8th grade. The NS stands for number systems. And then this stands for 8th grade expressions and equations. So we're going through 2 different standards there. We will have 4 lessons, one that's a mini lesson just on scientific notation, and honors you'll have 2 additional lessons that you'll need to go through as well. Our first lesson is on squares and roots. So you have on your calculator a button that looks like this. And we've already talked about this, so that means to the second power. So everything in math has opposites. Adding has subtracting, multiplying has dividing, squaring has what's called a square root. So you're going to hit, to get to your square root, you're going to hit second and then the x squared button. And your root, or this is called a radical sign, will look like that. So to show you on your calculator, mine's going to look a little bit different than yours just because mine's going to be long ways. But I'm going to open up the calculator. And your button, it will still be next to your 7. It says x squared. And then you can see right here how it has the radical, or that root. You'll notice anything in yellow, I think yours might be in green. Anything in yours on top here will be in green. You have to hit this second button, which is at the top left of your calculator, and then x squared, and to get that. So if I wanted to do it, I would do second and then x squared, and then it would pop up like that. If I just wanted my x squared, that's what it would look like. All right, to get any power, so that's just for the second power, and a lot of you guys will use that over and over again, but to get any power, it's this sign. Again, we've already gone over this, but that will raise it. This means raise to the power of, it's called a caret, and it will raise it to the power of anything. The one that we're going to work with mostly is a cube root. So if a square and square root undo each other, a cube, or to the third power, and a cube root will undo each other. So this one is the one that most people put in wrong. You have to type in 3 first, then second, and then the caret key. And if you've done it correctly, your 3 will go small and it will be up here. It should not be in front like this. That is wrong. That 3 should not be in front. It should be small and up top here. So just to show you, we would hit 3, 3, then second. Now your key does not look like this. Yours is the caret key, but it's right above the x squared. And you'll notice my 3 got small and is right tucked in between in that root. If you do it wrong, because I'll see it done wrong a lot, you guys will do 3, second, and then you'll hit the x squared one. Do you see how it stays big right there? It's not up the top there, and we want it up at the top there. All right, so those are what undo each other. So our radical sign, which looks like this, is used to indicate the root of a number. So this tells me how many times we want it to appear. This one, even though we don't see it, that one's 2 times. This one's 3 times. If it were a 4 there, it would be 4 times. So on your own, perfect squares are whole numbers times itself. So there's no decimals involved. So in other words, this means 1 times 1. I need 2, 1. So 1 times 1 is still 1. 2 times 2 is 4. 3 times 3. And just so you can see, if I were to put these in, if I were to do 3 squared, so 3 and then squared right here, you'll notice that it will give me 9. And so those are what I want you to put in. Whoops, wrong thing. That's what I want you to do. So if you need to push pause to fill those in, do that. All right, if you did them correctly, you should have 16, 25, 36 was already filled in, 49, and then 100 would be 10 squared. So when we take a square root, we could have 2 answers. We could have the positive and the negative of those. Mostly you'll just see the positive form, but you have to think that 2 times 2 will give you that 4, but so will negative 2 times negative 2. They have to be the exact same. So one can't be positive, one can't be negative. They either both have to be positive or they both have to be negative. So just to show you how to put this one in your calculator, and some of you already know that it's 5, but if we were to put this in your calculator, we would hit, we need to get to, let me clear this, we need to get to this square root right here. So we need to hit second, and then x squared, and you'll notice that comes up, and then I'm going to put in 25. When you hit enter, it will show you that you get 5 right there. So that means that I would get 5, or it could be -5, because 5 times 5 is 25, and -5 times -5 is 25. So I'll do one more with you, and then I want you to try the 2 on your own. So we'll do square root of 49. So I'm going to hit second, x squared, 49, and then hit enter, and I'll get 7. So I know that this one, I could do 7 times 7, or I could do -7 times -7. So try 144 and 169 on your own. Pause if you need to. If you did these two correctly, you should have 12 and -12. And then on this one would be 13 and -13. All right. Another thing that you're going to have to do is estimate where those non-perfect roots are. So like if we looked at 52, if we came back over here to these, we would notice that down here, we do not have a 52. We have something really close. We have a 49, but we don't have a 52. That's why this is called a non-perfect square root. So if you put it in your calculator, we would put in the square root, so second square root 52. And you'll notice it comes out with this decimal, 2.2. If it came out with a radical, we would hit our key here. Sorry, we'd hit this conversion key right here, and it would convert it. So our decimal is 2. Oh, whoops, that wasn't the number, though. It was 52, not just 5. So we need a 52 in there. So let's try this again. So second square, and then we get 52. So we can see this comes out 7.2. So when we come back to our notes, we know that we get 7.21. Well, that means that it's in between. If we were counting, if we were looking at a number line, where would we put 7.2? Well, it would be between 7 and 8. And the reason it's between 7 and 8, again, if we come back over here, we knew that the square root, or 7 squared, was 49. Well, that's close to 52. We knew that 80 squared was 64, so it had to be in between there somewhere. It wasn't in between 6 and 7 because 7 is only as high as 49. So we can see that it had to be in between these two numbers. So you're going to write it as the square root of 49 was 7, the square root of 64 is 8, so therefore it's between 7 and 8. So I'm going to show you 40 as well, and we'll show it to you both ways. So now I'm looking for my squares. If I were to square a number, I need to get as close to 40 as I can. You'll notice none of these are 40 down here. But 36 and 49, that means that the square root of 40 is in between these two numbers. So it's in between 6 and 7. So I could write, and we'll do the decimal form in a minute. I could say the square root of 36 is 6. And the square root of 49 is 7. And so this 40 is in between these two numbers, which means that this is between 6 and 7. The other way you could do it, again, you could put it right in your calculator, and we could say, I want second x squared. I want the square root of 40. And you'll notice that comes out as 6.324. So then I could say, well, decimal form, this would be 6.3. Again, if I were to place this on a number line, 6.3 is between 6 and 7. So I would know that it's between 6 and 7. All right, try this one on your own. And this one, the only difference is it's a negative on the outside. So when we look at this, we would have, when you put 12 and you're just going to put in your negative in between there. So you're looking at, where would this be? Is it between 1 and 4? Is it between 4 and 9, 9 and 16? So if you were to fill those ones in, we would say that this would be between, this would come out, if you were to put this in your calculator, it would come out as -3.5. To show you, we would have our negative and then second x squared, and it was 12. And you'll notice it comes out, I rounded it, so that's why I said 3.5, but negative 3.46. So we know that negative 3.4 is in between 3 and 4, right? And that's because the square root of 9 is 3, and the square root of 16 is 4. So we know that this has to be between a negative, this answer is going to come out between a negative 3 and a negative 4. If you have not done this one, you need to do that one on your own. The last thing you're going to work with are cubes. And these ones are the ones that are, instead of to the second power, they're to the third. So this would look like, and we've already done something like this. This would be 2 times 2 times 2. Well, 2 times 2 is 4 times 2 more is 8. And we can also put this in. So like 4 to the third, we would put in 4. And again, yours is the caret sign. It's still right above x squared, but it's the caret sign. And so it's going to do the exact same thing. It's going to look just like that. And then we're going to put in a 3. This means 4 to the third power. And you'll get 64. 5 to the third power. You're going to do 5 and then to the third power. And hopefully you get out 125. And the last thing will be cube roots. And we're going to little bit with cube roots and cubes, but our big focus is going to be on squaring. So again, this is the opposite of cubing. They undo each other. So it's the opposite of something like this, x to the third. The opposite is cubing. So we're saying what number 3 times gives us a negative 512. So I know it has to be a negative, so we're going to put this one right in. And these are the ones that you'll put in wrong. So we're going to do, just like, let me go back to our notes real quick. Our notes say you hit the number 3, then we hit second, and then you hit your caret key. So I'm going to hit 3, then I'm going to hit second, and then I'm going to hit my caret key. And then I'm going to put in the number negative 512. Hit enter. You'll notice I get out negative 8. That means that negative 8 times negative 8 times negative 8, and I'm going to show you negative 8 times negative 8 times negative 8 should give me that 512 negative, which it does. So this would be negative 8. Now put these two in and check to see how you did on them.